Hello, hi guys, and welcome to our lesson on statistics. In our previous series, we looked at measures of central tendency, which included mean, median, mode. Also know that we are looking at descriptive statistics still, and today we'll be looking at measures of variability, and we'll be looking at how, when we talk about measures of variability, we are referring to how spread apart or how dispersed our data is from our mean. And then examples of measures of variability or measures of dispersion, we have the range, we have the mean deviation, the standard deviation, the variance. We also have things like coefficients of variation and the rest of them. So, but for this lesson, we'll be looking at basically mean deviation. We'll be looking at variance and standard deviation. So maybe subsequently we'll look at other forms of measures of variability. All right. Now, you should also know that in the calculation or in the working of this, you could approach it in two ways. We could have calculations that have to do with ungrouped data, and then calculations that have to do with group data. All right. Now, so we'll be looking at calculations that have to do with ungrouped data first before we jump into group data calculation. So what we have on the board is calculations that have to do with ungrouped data. So we have an example on the board. They said from the following data below, we should calculate the mean deviation, calculate the variance, and then the standard deviation. Okay, we can even add calculate the range. All right, but let's leave that one for next series. Now, first thing that you need to do, you are asked to calculate mean deviation. The first thing that you need to do is to calculate mean, right? Okay, because you cannot find the deviation of mean without knowing what mean is all about. So, and we know that the formula for mean, right? These are our data first. These are data, okay? So for formula for mean is summation x over n. Remember, this formula is for ungrouped data. Now, so summation meaning we are adding all these values together. We add all the values together. All right, the n stands for the whole number, which is 11. So we add the 5, the 6, the 4, and all of that. Everything over 11. And then if we add up everything, we get 61 over 11. And when you divide 61 by 11, you have 5.5. All right? Now that is the mean. Remember, this is the first thing you need to do before you calculate for mean deviation. It's like a requirement, a prerequisite for you to calculate mean deviation. Now, after you've done this, you bring out these same data again, these your values, and then place it this way, place it vertically. All right? Now, when you do that, your mean is what? Your mean is 5.5. So for this first x, which is your value, right? X minus your mean. This is your mean. Our mean was what? 5.5. So if you minus 5.5 from 5, right? That is 5. Your x here is what? 5. And then your mean here is 0.5. So if you say 5 minus 5.5, it will give you minus 0.5. Okay? Then if you square this answer, that is minus 5.5 times minus 5.5, it will give you 0.25. Now, then here, you have the same thing. 6 minus 5.5 will give you 0.5 or just 5.5. If you square your answer, you have 0.25 again. Then 4 minus, your 4 is your x here, right? Minus 5.5 again will give you minus 1.5. Minus 1.5, square it, you're going to get 2.25. And then you do like that till you get to the last number, which is 7 here. And then you also do the same thing till you get to the last answer. Now, with this information, we can go ahead to calculate our mean deviation. So allow me to use this side for my calculation now. Now, so mean deviation, maybe I'll just write MD, right? The formula for mean deviation is summation open bracket, x minus x bar, right, over n. Now, I guess you are asking, what is this symbol? What does it mean, right? The symbol actually stands for modulus. Now, modulus actually means to ignore the signs, because if you notice, we have minus 0.5 here, minus 1.5, minus 2.5, minus 0.5, and the rest of them. If we want to add this column, right, and we are putting modulus sign, it means we are ignoring these signs. We are not adding with the minus. Do you understand now? So our formula again is what? Summation of x minus x bar, minus x bar, which is this column. So we add everything up, but remember, we are not adding up with the sign. And everything, if we add up everything, we have 13.5. So that means our mean deviation is equals to 13.5 all over, what is our n? Our n is still what? 11. Alright? So if you punch that on your calculator, alright, your mean deviation will be equals to 1.22. Alright, so that is for mean deviation. Alright, that is for mean deviation. Now, the next question we are asked is to calculate variance. Alright, we should calculate variance. Let me use this upper part. Alright, variance. Now, variance, the formula for variance is x squared is equals to summation, open bracket, x minus x bar, right, close bracket, then square here, everything over n. Alright, though some authors still believe that there is a minus 1. So anyhow you do it, even if you put a minus 1 here, the difference is not going to be significant. Okay, so that is the formula for variance. Alright, now if you notice, we have this column here. This is to sum. We have to sum the whole of this column, and we already have this column here. Alright, so all we need to do now is to add up all this column. And when you add up all this column, you get 23. Okay, so that means we'll say what? 23 over 11. Alright, now 23 over 11, if you divide it on your calculator, you are going to have 2.09. Alright, so approximately will give you 2.1. Alright, so this is approximately. So that is your variance. Okay, I guess it's not hard, right? That is for variance. Now remember, all of this is still ungrouped data. They are not grouped. Now let's calculate standard deviation. Okay, let me use this side. Now standard deviation, I can just use S to denote standard deviation, because the formulas for variance and standard deviation are actually related. The difference is that in standard deviation we have a square root, right? So it's equals to summation x minus x bar, everything squared, all over n. Then you now put a square root sign. Okay, do you notice that the difference between this and this is the fact that this does not have square root, but that one has square root. So what we'll do now is that means all of these values will still be the same, right? So we say standard deviation is equals to 23 over 11. We'll put everything in square roots. Standard deviation is equals to 2.09. Then we'll put everything square root. And then your answer, if you do that, your answer will be 1.44. All right, 1.44. So that is basically how to go about mean deviation, variance, and standard deviation, particularly when it has to do with ungrouped data. I hope you enjoyed this video. Thank you very much, and see you in our subsequent lessons.